Geometry. Geometry, algebra. Yeah, that makes perfect sense. Geometry, we've got chapter 4, section 5, which is dilations. Think about getting your eyes dilated when you go to the optometrist. What it does is it makes your pupils get enlarged and they get really big, and then eventually they will go back to their normal size. So a dilation is just either an enlargement or a reduction of something. So let's say that I had a distance of 12, and then I had a distance of, let's say, 8. So this is 12, and this is 8. And so if I did a comparison, let's say this is line A to line B. If I compared A to B, that would be 12 to 8. And that would give me a scale factor. If I reduce that by 4s, that would give me a scale factor of 3 to 2. And if I'm comparing A to B, obviously A is larger than B, so the numerator is going to be larger, and this is an enlargement. Is there an E there? I'm not really good with my spelling. That is true. There is an E. That is an enlargement because my fraction is greater than 1. I'm comparing 3 to 2. If I go the other way, okay, so this was A to B. If I compare B to A, obviously I'm going to have 8 to 12, which is 2/3. And because my fraction is not greater than 1, then that makes this a reduction. So just watch your order in the things that you do. C-I-O-N. And that is your basic dilation. That is an enlargement or a reduction. Now, we're also going to do one in class, an actual manual enlargement. So we'll do a dilation of a shape, and I will show you that in class tomorrow. So you may also see something, they give you the coordinates of something, let's say triangle ABC. Okay, so that triangle ABC has coordinates of A 2, 1, B 4, 1, and C 4, -1. And we're going to map its image, this being the pre-image, we're going to map its image of A prime, B prime, and C prime. And so if it's a scale factor of 2, that makes it an enlargement. And I'm just going to enlarge all of my coordinates by a factor of 2. So I multiply each of them by 2. And it would look something like this. I'm taking 2 times my x and 2 times my y. So that's going to make my A prime 4, 2. That's going to make my B prime 8, 2. And that's going to make my C prime 8, -2. Now, obviously, that could be, that is an enlargement. We could do a reduction where it was 1/2, where I would take half of 2, half of 1, half of 4, half of 1, and so on and so forth. We can also do a negative reduction, where it will not only make it smaller, but it also might change its orientation. So I want to go ahead and look at a negative dilation or a reduction. So let's say I have a triangle again of ABC. Let's say A is 6, 8, B is 2, 4, and C is 0, 6. So if I were to graph that, which they will ask you to graph some, I'm saving a little time in the screencast and not graphing everything. Let's say that I did that to a dilation of -1/2. And so just like in the other one, what that means is I'm going to take -1/2 times x and -1/2 times y. So basically what I'm doing is I'm taking half of it and then I'm changing the sign. So that's going to make my A prime, half of that 6 is 3, and I'm going to change the sign, so that's going to be negative 3. Half of the 8 is 4, change the sign, negative 4. And do the same with the B. Half of 2 is 1, I make that negative 1. Half of 4 is 2, I make that negative 2. And I guess I chose all. You know what? I'm just going to change this real quick because I can. Let's change that to a negative 6 so we can see something a little bit different. In the bottom one, half of 0 is still 0, and that's not positive or negative, so that will just stay 0. Half of 6 is negative 3, and then I change the sign on that one, so that will make it 3. So that is a negative dilation, which is actually a reduction because it's 1 to 2. And that's about 6 minutes worth. That's about all we have on Chapter 4, Section 6. Again, we will do some constructions in class tomorrow. 4-5, Section 4, Chapter 4, Section 5, Dilations.